Hello everyone, my name is Greg and I dev stuff. This is my first episode of tutorial how to do game like Total War in Unity. We're going to use a job system. For this we will have to pull out and latest packages. We're going to use ECS, so this is another package which we must to install. For a good performance in games like Total War, we definitely need to use CCS because we will have to simulate a big amount of different models. This is quintessential pretty much. Let's wait until I'm done with installing all the packages. So let's start. First of all, let's create a script player input component. Let's go in, small mistypo. When we go in, we're going to pretty much create an iComponent data. iComponent data is something like a container. Imagine a class for entity data. I'm going to explain this stuff later on. We serialize it, of course. It is for so we can later on serialize it for saving data. Now let's pretty much introduce all of our possible control inputs like left click, right click, mouse wheel, mouse position. We're going to use a float 3 from mathematics because it's much more faster and we don't need stuff like vector 3 up on our mouse position. Now let's do a component data proxy player input so we can attach player input component later on to any game objects. Let's create player input system. Inside this player input system, we're pretty much going to interact with all player input components. To do so, first of all, we have to inherit from job component system. Then we're going to use jobs, of course, and Unity mathematics for later. We will use Unity mathematics for float 3. So let's introduce our new job, player input job. When we introduce a job, we must to define with what this job will interact with. In our situation, we will use iJob for each player input, so it will interact with every entity present in our scene and do what is inside execute function. So after this, I introduced all appropriate variables which we already have in our player input data. It is a workaround because we cannot just directly access and static variables from our job. So we will assign to these variables and appropriate states from Unity input system. So now let's introduce an onUpdate job from job handler. onUpdate pretty much work close to how Unity update works. It fires up every frame and we can interact or assign proper jobs on our onUpdate every frame. So we're pretty much copying how monobehavior input system works, just through a much better and more efficient way. Let's create a temporary variable job and assign all appropriate variables to each other. So it's pretty simple. You just access input, get mouse button down, or get access for scroll wheel. If you want to introduce some other, you can use an input system as overall. Now let's return this new job and schedule it before it. Let's create a prefab which we're going to make into entity. So it's very simple. It's same process as always. Just make an object, let's say cube. We will make a material, so we will see it. We must check the GPU instancing. For testing purpose, I will just make it red. And, you know, usual way to make a prefab. Now let's create spawner data. Spawner data will contain a reference to one base entity. We cannot just simply put a prefab into ECS. We must actually make a prefab and convert it into entity. And this spawner data, component data, will contain reference to this entity. Now we're going to create a script spawner system. Uh, in the vein of input system, it is pretty much the same idea that this is the script which will process our job, which will operate with our spawner. So first of all, of course, when we create a script spawner system, we inherit from job component system. Of course, we need to introduce jobs. I immediately introduced entities because, you know, we're going to use them. Then I am going to initialize the most mouthful thing ever. Begin initialization entity command buffer system command buffer. Thing is, we cannot just directly interact with entity manager inside the job. We have to use some kind of workaround, and this workaround is command buffer. We pretty much throw into command buffer a command and then process this command later on through job. Then I introduce mathematics, so we will have a random class in our script. We will use this random to make some kind of deviation in position later on. Now I introduce a new job, and it will be job for each with entity. This is a pretty simple idea that every entity with player input and spawner data will have this job interact with them. You seen me fixing a small bug. Sometimes if for some reason you have some kind of error, check does your data structures, IData components, sorry, is struct and not class, because it's a very common mistake I do. In the job I introduced command buffer for same idea as I said before, and it must be entity command buffer concurrent. Another thing, I introduced a position to fill it up later, and now inside the execute method I will use our incoming player input, as it's always like, you know, in Unity input class, just call if left click, therefore do something. After the instantiation, I just add set component to same thread. Right now we just instantiated a new entity, and this component will be a translation because our entities does not use transform. We're going to use translation for positions. Now let's go into job handle on update. And on update we're going to do the same thing as in previous system. It is just initiate a job, fill it up with necessary information, aka their variables. It's a command, we need to add a command buffer reference and random position, then schedule it immediately. After this we're going to go into command buffer and add job handle for producer, sorry, and then return this job. We're nearly done. Let's create a spawn point. It's just an empty game object, and add a spawn point proxy, because we cannot just simply attach spawner system or spawning component. We need to use some kind of proxy, which is like a some system which transform our data into entity. First of all, we will add requires entity conversion. When it's put into the script before declaration, if you put this component, the script, on any game object, it will show you the warning that this game object must be converted to entity. So you will have to add the appropriate script of conversion. Now we will add I declare reference prefab and I convert game object to entity. Thing is, we cannot just simply add prefab and use it as an entity later on. We need to declare it beforehand. So we will make a reference point for editor public game object prefab. Then we declare it. Right now I introduced a convert method interface from iConvert game object to entity. It is pretty much firing up when you convert a game object to entity, and this allows us to add necessary data into our entities. So now we will just get from conversion system get primary entity. This command allows us to get the reference to an entity which we use as a prefab pretty much. Then we pretty much add a component to our newly created entity, which in our case is a spawner data. Then we're going to introduce an input system, sorry, it's player input component, and just add the component to our entity. Now we just have to add convert to entity on our spawn point object on the scene and spawn proxy. Then add a prefab reference, and to our main camera I will add player input player input component so we can test it. Let's run it, and if we press left mouse button it should create, yes, it's creating a small red cubes. This is an introductory video, it's just the first episode and I hope it will improve with time. I'm sorry if it's very hard to follow. Thank you very much for listening and watching.